Yeah, thank you. Hello everyone. My name is Sangmin, and you can call me Sam. I'm from Klaytn. It's a public blockchain. It's an EVM public chain. So today I'm going to talk about bridges. The cross-chain bridges have been, sometimes issues and sometimes, they're creating a lot of values. But uh, yeah, today's topic is about how we can get more trust or trustless bridges. So this is me. Yeah, let me skip this. So, the bridges have been kind of an issue because of there are a lot of hacks, especially these days, from since the 2021 at the moment. Uh, yeah, from the analysis from chain analysis, there have been lots of hacks, and the amount of assets stolen by bridge hacks was increasing a lot. So, if, okay. If you look into the details about the hacks, especially about the amount of values that's stolen especially in 2022, these are just some examples of the huge hacks. So from the Walmart, the Lonin, and then Nomad and Binance things. So over 1.4 billion US dollars were stolen by breach hacks. Yeah. So then what is the cross-chain bridge? The cross-chain bridge is a protocol basically connects different blockchain ecosystems by ensuring the compatibility and interoperability between them. So basically the bridge brings the quite values, especially in DeFi area, by securing the access between these two chains and providing an infrastructure that can allow users to transfer assets from one chain to the another. So, we have a lot of bridges in the industry and across the chains. So we have surrounding Ethereum, we have different bridges on the customer and the customers, between customers and Ethereum, and between Ethereum and Polkadot. And these bridges are sometimes a trusted one, and some of them are trustless ones. So, and also they are supporting EVM chains and sometimes supporting tandem chains and so on. And some of them are just general purpose bridges. So we have different mechanisms and different operation models for different bridges. So let me briefly introduce some of mechanisms that are used for implementing bridges. The one mechanism, the simple one, is the lock and mint. So basically, let's take an example of Walmart bridge. So we have Ethereum and Solana. And so in this way, in this mechanism, the user first send the transaction to the Ethereum, and there is a smart contract for the bridge. So that bridge contract basically locks the tokens on Ethereum, and then is sent to the cash to Solana. And on Solana, there is also a smart contract that's basically minting a new token. Basically, it's a wrapped version of the original token. So in that way, so this is what called like lock and mint, because the asset is locked on one source chain, and the wrapped version of the token is minted on the destination chain. And in most implementations in this mechanism, there are also validators in the middle. So in the middle, these validators, or sometimes they are called operators, they are basically monitoring the events on the source chain and then send the transaction or send the request to the destination chain. So validators could be centralized, or sometimes could be decentralized. The second mechanism is the liquidity network. So instead of relying on validators or operators, there is a liquidity pool in the middle. So we have source chain and destination chains, and the liquidity pool basically maintains the original tokens in the form of original token, and so the liquidity pool maintains the tokens in the source chain, and also it provides the original token to the destination chain. So as long as the liquidity pool has tokens, and then the users can transfer their token from one chain to the another. So this is so so this actually has a benefit over the lock and mint mechanism because it doesn't have to rely on the centralized entity. So as long as it has a liquidity pool, but the problem is it's hard to maintain the liquidity pool because if we don't have enough liquidity in the pool, then we cannot transfer token between the different chains. So then, yeah, there's another the categorization of the bridges based on who are operating or who are in the middle for cross-chain transfers. And so the one type is we have external validators and federations type. So we have these different bridge implementations, and they are relying on external entities for validate cross-chain transfer validations. And also sometimes there's a decentralized group who are basically monitoring and transferring the assets. And the second type is a light client and relays type. So this one actually a kind of trustless implementation. Instead of relying on the validator set, it actually generates a proof for the transfer on the source chain, and then it sends the proof to the destination chain, and the smart contract on the destination chain actually verifies the proof from the source chain. So basically, it relies on the cryptography, and sometimes it uses GKP for proving the original transactions. The third type is the liquidity network that I mentioned before. So these are basically the three types of bridge implementations, and based on the who are managing the transfers. So yeah, let me skip this. I put too many slides here. So okay. So, but I mentioned about the bridge hacks in the beginning, but actually from the design perspective, there are some vulnerabilities based on what design is used. So for example, so but for example, still I mentioned different types of implementations and different types of mechanisms for bridges, but the bridges are still in the early stage in terms of development, in terms of technology. So there might be some smart contract bugs or software failure and the human errors and so on. So because of this immaturity in technology, we still have to do a lot of audits and a lot of code verifications. But still, if there is a bug, then you the is the breach hacks could happen. And not most of them, but some of the breach hacks that we encountered in the history were caused by this kind of error. And the second vulnerability that I really want to emphasize here is about the breach operators. Because many breaches were implemented using validators, but if the validators are malicious or they are not doing well for the management of their private keys or the security, then there could be a security hole in the middle. So in that case, because of the breach operators, there could be a lot of hacking, and that could happen. And also, there's a risk on the censorship because we have to trust the validators in the middle. But if they are not, trustful, and if they are not managing well the breach, then the breach could be stolen. I mean, the asset on the breach could be stolen. And also, we have a custodial risk, and because the breach operators could collude if there's a huge amount of assets in the breach, then there could be a problem. So in that sense, we need a trustless breach to mitigate or to eliminate the risk of this operator and in the middle the middleman problem. The trusted bridges are basically depend on the central entity or system for their operations. On the other hand, trustless bridges basically operate bridge using smart contract and algorithms. So there's no middleman. And so basically they are trustless because they don't use any entity. They just use smart contract and also uh, sometimes uh, the node implementations. So then let me talk about the example of the bridge, trustless bridge on Klaytn. So for those who are not familiar with Klaytn, let me briefly introduce Klaytn in one slide. So the Klaytn is the EVM compatible public layer one chain. So we launched this mainnet in June of 2019, and it's been more than 3 years. And because although it's an EVM compatible chain, we use different consensus algorithm. We use Istanbul BFT, and the Istanbul BFT is run by the governance council. Currently, we have 33 members, including those guys. And we have a unique account and transaction model, and we are currently focusing on metaverse and games. And from the perspective of performance, the Klaytn provides 1 second finality and over 4,000 TPS, and the gas price is much cheaper, and we have a dynamic and deterministic gas price model. So, so we have been working in many game projects, and the game projects are using our sidechain solutions, and that is called the service chain. And between mainnet and mainnet is Cypress, and mainnet and their game chains, we have bridge between them. So, but these bridges are kind of a native one that are provided by our service chain implementations. But these bridges are relying on the operator. So operators are typically the service chain maintainers or operators, but there are still problems and trust problems for this bridge because this bridge is relying on that operator. So we are designing a trustless bridge for this trustless bridge for Klaytn and other chains, especially service chains that are used by games. So the goal is, of course, the transfer access between Klaytn, mainnet, and the service chain without operators or validators. I mean, here operators are the bridge operators. And the problems that we are tackling is how we can verify actual cross-chain transfer transactions without relying on centralized validators. Actually, I gave a hint for this. So our approach is let a user self-verify transactions on one chain were correctly processed on the other chain. So we have main chain here, and also we have bridge contract, and we have service chain, and the service chain also has a bridge contract. And the user just finishes its own transaction on the main chain and requests to the transfer to the service chain without relying on the validator, and just send the transaction to the service chain. So to do this, we have to solve this problem, and we have to actually prove without validators. The proof is like, so we have to prove the transaction was correctly processed on the main chain by validating transaction receipt and market pass and block header. And also we have to verify, because we are using BFT, and we also have to, the consensus was correctly made on the main chain. So we have to also verify the signatures on the main chain. So yeah, time's up. So let me conclude. So next step, because we are doing a lot of POCs, so we'll complete the design, and also we'll generalize the idea and the design, and then make bridge between Klaytn chains and between EVM chains, and then later we'll open source the implementation and design. Thank you, everyone. And if you need more information, please scan the code. Thank you.